Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI-powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future. Today, imagine you're an AI agent trying to reproduce a research paper's code. It installs dependencies, crashes, fixes something, breaks something else, and worst of all, it forgets what it learned last time. Today's story is about fixing that. A paper called Revere, Reflective Evolving Research Engineer for Scientific Workflows by Balaji Dinesh Gangireddy and Aniket Garikaparthi. So what's the real problem? Most LLM agents don't actually learn over time. They optimize prompts locally, rewrite everything, and lose useful knowledge. In research workflows, this becomes chaos. Different repos, missing dependencies, vague instructions, weak feedback. So every task feels like starting from scratch. Revere changes that by giving agents memory and reflection. Think of it like this. Instead of rewriting its brain, it edits specific thoughts carefully. It works with three key fields: system prompt, task prompt, and a cheat sheet. Now here's the magic. After running tasks, a reflector agent analyzes failures. It finds patterns, not just one-off mistakes. Then it updates only what matters using code-based edits, not rewriting, just surgical changes. And everything gets stored in a global training context. So knowledge accumulates over time. Let's break that global context down. First, the cheat sheet. This is like a growing notebook of practical tricks. Check dependencies, validate configs, things that actually work. Second, reflection history. This keeps track of why changes were made so the system doesn't contradict itself later. Third, auxiliary context. It looks at future or unseen tasks so it doesn't overfit to the current one. So instead of reacting, Revere starts anticipating. Now, how does it actually update prompts? Here's the clever part. It writes small Python programs not to solve the task, but to edit the prompt itself, like replacing a vague instruction or adding a missing step. These edits are targeted, expressive, and safe because they run in a controlled environment with filters blocking dangerous operations. So, does this actually work? Yes. And consistently, Revere improves performance across benchmarks like Super, Research Code Bench, and Science Agent Bench. We're talking about improvements up to 4.89% over state of the art without retraining the model. Even more interesting, it's up to 10x more cost efficient. And unlike other methods, it doesn't collapse when given more feedback because it learns patterns, not just outcomes. There's also a deeper insight here. Most failures weren't about algorithms, they were about environment issues, missing data, wrong configs, broken scripts. Revere turns these recurring problems into reusable heuristics. But it's not perfect. Here's a key pitfall. The global training context keeps growing. Over time, it can become heavy or include outdated knowledge. So managing and pruning memory becomes critical. Practical tip: keep heuristics concise and prioritize reusable patterns over detailed logs. So what's the big takeaway? Revere shows that LLM agents don't need retrain to improve as done. They need structured memory, reflection, and precise updates. And this might be the first step toward agents that truly learn like engineers. What happens when this evolves further into fully autonomous research systems? If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.